Okay, thank you. First of all, I want to thank Valgray for giving us the opportunity to present our work. The work is an intelligent transport system for safe route recommendation. This is part of a project that we just finished this month of June. And it has been done in the frame of the Applying Intelligence and Research Group from Universitat Jaume. And we have collaboration in this project with the Department of Mathematics, also from our university, and also with the Integrated Laboratory of Intelligence Systems and Technologies of Traffic Information from the University of Valencia. And in the last part of the project, we have the collaboration of the company, Vanderberg ICT and ITS Solution, that is very interested in the algorithm that we are developing. The idea of the project was to support traffic management because even nowadays, traffic management is done in a centralized way. And it implies a lot of problems because we have several data with poor quality and we need to analyze it very well. And furthermore, there are two other problems: that the decision of the driver are totally self-interested. We as drivers know the situation. And also the modeling of the traffic is quite complex. Traffic has a complex behavior, and we need a lot of parameters and a lot of information in order to define what is the real traffic status. For example, for us as human, in the top image, we can see a part of the road network, and for us it's very easy to understand that this is a motorway with several lanes, with several intersections, with some kind of hazard, etc. But we need to put all this in a knowledge model. And okay, we can put this as a graph, for example, with links and nodes, but we need to add more information. And if we go to model the traffic, there are more problems. For example, we have this, and for us it's very easy to understand that there is a congestion here, and there is a no congested area here. But the traffic flow in these two areas is the same. There are only 2 cars passing in this area. Why? Because there are so many vehicles here. So speed is so low that in this period of time, there are only 2 cars passing there. And in this area, there are few cars, high speed cars. They drive at high speed, but there are only 2 cars. So we need more than 2 parameters to define this. This is the same situation with this. This is all the cars that they throw in a section. We have 1 car that is 160 kilometers hours of speed, but we don't know if we have only this spot. We don't know how many cars are in this segment. So it's quite difficult to model the traffic if we don't have more information and if we don't have a relation between the parameters and the information that we have. So to solve this centralized problem, we found that multi-agent system were a good paradigm to modeling traffic and transport domain. This is not new. There are several examples in the literature, and our idea is to present some multi-agent system that present a distributed approach with more flexible individual decision making for drivers, and that try to implement the autonomous behavior not only of the individual drivers, but also of the traffic itself. So our idea was to model the knowledge with several layers. Our idea is to implement or to be able to model from the real data to some kind of stored data that able to individuals to model traffic. So we create several layers in order to make easy the upgrading and the updating of this layer and the knowledge inside these layers. So we have the road network model that models the topology of the road network. We have the traffic knowledge model where we put not only the traffic parameters, but also the relationship of them. And in this, we can put also quality measures in order to avoid or to detect errors in the measures of the traffic. Then we have the agent model that model the agent that represent the knowledge. And also it's needed to have an interaction model that allows the individuals to interact between them. So the architecture we have a lot of agents, but for this presentation, mainly I focus in 2 agents. The segment agent that is responsible of manage some part of the road network, and the vehicle agent that he drives through the road network and he flows from one origin to a destination. And usually we try to do this travel in the less time possible. So in our system, these two main types of agent, the vehicle agent has, of course, some part of the knowledge model, and we model different intelligent vehicles. It depends on the communication that we model. For example, we have vehicles that no communication at all. There are no internet on board, so they don't know anything about the traffic status downstream. We have also vehicles with the capacity to communicate with the infrastructure. So they receive information from the road equipment. And also we have vehicle-to-vehicle communication that vehicles are able to receive any kind of communication from other vehicles ahead or in the opposite side, etc. And then we have the segment agents that also, of course, they have the knowledge model, and they are responsible for analyze the traffic in his road network. So the analysis that we have developed is a macroscopic analysis. We use the Greensight model. We focus on speed, on traffic flow, on capacity and density, and we don't focus at the moment in the individual vehicles. We don't take into account acceleration. We don't take in account the changes of the lanes, etc. So it's more or less a macroscopic approach than for us is important the travel time in the itinerary. So this analysis is done using the current traffic status, the current traffic trends, the comparison of this data with the highway capacity manual, that is more or less the Bible of the traffic engineering, and we also analyze the historic data in order to focus the data with any possible deviation. And in this project, the thing that we add to the segment is the capacity to determine or to forecast traffic incidents. So we use some Bayesian model using inland SPDA that I will focus later that provides us some kind of likelihood of the incidents. And this has been implemented in the segment agents. For the implementation of the project, we use NextLogo. That is a platform that it's easy to implement multi-agent system, and it is easy also to manage complex systems. So we consider this platform is adequate, and we create a framework that we have different, and the framework allows us to include road network from open street maps. It is very easy to determine which road network we want to model. We import this road network from the open street maps, and then we have to structure and to present the agents inside it. We have this big one is from Castelló to Benicarló. This is a little big one from Sagunto to Nules, and these are two bigger with more than 200 kilometers. This is the road network of the Valencia and Castellón, and this is the area. This is small, but this is the area of the influence of the harbor of the Rotterdam harbor in Netherlands. This is a biggest area that we are focusing now in this area in our work. We are able to capture or to simulate several situations, and we have developed several tests. And only to present one is as more result. As more intelligent car we have, if there is an incident in this segment or downstream this segment, we are able, or with the system, present that as more intelligent the vehicles are in the system, the more vehicles avoid this segment because they have the information of other vehicles or the infrastructure that there is a problem there. The travel times is increased, and the intelligent cars avoid using this segment using other alternative routes. Well, but as I told before, the idea is not only present the best itinerary using the travel time, but also to include some safe route recommendation. So the idea is that vehicles are able to find itineraries with the less probability of finding incidents along the route. So we try to do it during several time frames, when the traffic characteristics are similar, And the proposed solution is, okay, we have to combine the traffic status in each segment with the travel times in the itinerary that the vehicles has chosen, but also with a risk map where the incidents can be produced. So to do this, the incident analysis has been done using a spatio-temporal statistical model. We use a Bayesian methodology that integrates nested Laplace approximation and stochastic partial differential equation. This model can predict the likelihood of traffic incidents in any future data, and we use it to improve the traffic status in the segment. We are testing this in the Netherlands. As I told you before, this is the network of the environment of the harbor in Rotterdam. This is the harbor of Rotterdam, the city of Rotterdam. This is Utrecht, and Amsterdam maybe somewhere here. Okay, the first that we do is we use the data from the National Data Warehouse from Netherlands. They provide us the information, but they send us all the incidents on all roads, not only on motorways, but also regional, national, local. So the first thing that we have to do is, okay, we only need to test and to analyze the data that are in the segments or in the road network that the agents are in charge of. And then we found another problem, that sometimes the incidents are not located in the segment. This is usually due to two main reasons. There are some kind of errors of accuracy of GPS or Galileo or Copernicus satellite, but also we have problem because there is a big incident and the car goes out of the road segment. Maybe sometimes it is out of the hard shoulder, it is in the countryside, some kind of 100 meters, etc. So the thing that we do is the segment analyze this data, and they shift this incident to the nearest road segment. Then when we have the incidents, we start the statistical model. Only as an example, between these two dates, less than 1 month, we found 244 accidents. And I say accidents and not incidents because there was several incidents in there that are not quite important for us. We need to detect the incident that has some kind of impact on traffic flow or on the travel times. So then we analyze, we start with some statistical model. First of all, we do a convex hull boundary of the whole network. Then we start the SPDA triangulation, and then we mix, that this is a new part of the project that has been done but for our colleagues of the mathematical department. They put this boundary with the network, and then we create a SPD triangulation inside our road network. So with this, we were able to provide some kind of likelihood of the incidents in the different segments. We use different models in order to determine which is the better or the best model to analyze this likelihood. And as more at the moment, as more covariate that we include in the system, better results are provided. And that doesn't mean a very high increase of time in order to calculate this. So we use the model 4 that we see here, for example, that the observed incidents with the predicted ones are quite similar. So we consider that model 4 is a very good approach. And then we analyze the integration of the risk map, and we classify the incidents in the segment in several groups. First of all, we classify to analyze the incidents, the probability of incidents. We split the days, or we classify the days that the incident were produced. This is a typical classification of traffic engineers, that there is Monday, Tuesday, Wednesday, and Thursday, Friday, Saturday, and Sunday. And we thought that Monday is, for example, now that we are in summer, there are a lot of people that is outside the city in the second residence, and on Monday they come to work, they drive to the city to work, so there is an increase of the traffic flow these days, and this is not usual the rest of the year. And then also during the day, we classify in peak hour morning, valley hour, and peak hour afternoon. So this is the typical classification for traffic engineers, and we use it. And we don't use the night because there are few incidents in night period, but also if there are some incidents, as there are few traffic flow, this incident has no relevance for the traffic flow or for the travel times. So using this information, we combine it with the traffic status of the segment, and we produce some kind of qualitative level of service in order that the segments are able to provide this information to vehicles, and the vehicles determine the route that they want to use. Currently, we are improving this system. We try to use reinforcement learning for each segment in order to improve the qualitative level of service, and we are in this phase. And before to end, I want to say that we are transferring this result, as we talk about. We are working with the ICT, with Vanderberg ICT consultancy company that is very interested, because this company has the software in 3 different traffic control centers near Rotterdam. So the company is very interested in the process of determining the incidents. And now we are working with him, and the idea is, okay, we have some web services that we take the real-time information from the Netherlands companies. We put this in our knowledge model. Then we do several simulations about the traffic status. And this part of the deep learning process is the part that I'm talking about, that we are trying to improve now in order to determine or to forecast the traffic status in short time periods. And then the idea is, okay, all this information will be put in a dashboard. The road operators will have this information, and they can act and they can take the traffic measures that they want. This is an example of the draft dashboard that we are working now. You see, we have the road network, we have the segments agents with the information. This is the information of the traffic status on the itineraries. And on the bottom, we see 2 graphs. This is about travel data, and this is about CO2 emissions. The red line represents the forecasted traffic, or the traffic that NetLogo simulation thinks that, or has the result of the simulation. And in green is the real traffic time, or the real traffic status that the loops or the traffic information on the roadside is telling us. So here we show that there is a big difference, and this is happening because there was some kind of incident here. So when the road operators saw this difference, they can say, or they can act before, because there is some kind of problem. This is not the traditional behavior of the traffic in this segment, so they can act before or as quick as possible in order to change, for example, the information in the BMS or the information to send to drivers. And to conclude, I want to present some future work. The idea is to analyze and to improve the risk map. The company told us that this was a very good idea and very good implementation, but we need to have a system with more accuracy. So we are analyzing different time periods, 1 month, 3 months, 1 year, but also we are classifying the months. It's not the same July than February, or it depends, for example, I assume in all Europe, but specifically in Spain, it depends on Easter holidays. It's not the same that Easter is in March, that Easter is in April. So we need to know this in advance in order to analyze the data. We also want to analyze the type of vehicle as a covariate in the system. We thought that this is very important. It's not the same to have an accident for a light vehicle that accident of a truck, or an accident of a truck with heavy dangerous goods. But the question is, we have some kind of administrative problem with this because there are some private information. When usually we have the information of the type of vehicles, there is the number of the insurance there or the number of the license plate. And we are trying to sign some kind of agreement in order to do this, but this is some kind of administrative process. And this is a problem for your university, but also for the Netherlands administration. So we are stopped here to add this. We also want to increase the precision grid. We want to transfer the intelligent behavior of segment to forecast traffic. We want to put this in the vehicle in order that vehicles, if they have its own information, they also can select, or they also can forecast traffic on their own and then select the route. As I told, the idea also is to apply machine learning of the prognosis of safe traffic. We are trying to do this to improve the combination of traffic status and the likelihood of incident. And we are starting to integrate the European common emission model in the platform in order to forecast not only safe itineraries, but also sustainable, in order to avoid that there are some kind of congested area. In fact, this is a thing that we are doing in Spain in cities. Sometimes there are some vehicles that cannot drive in cities, and why not it can happen on peri-urban areas. So our idea is to model this in order to forecast this kind of sustainable itineraries. And this is all. Thank you for your attention. If you have any question.